Alright, hey guys, so today we're going to go ahead and go over day 4, bond polarity. So if you guys can just go ahead and follow along in your packet, I'm going to go ahead and just use the slides. If it decides to work with me today. Okay, alright, so bond polarity. In polar bonds, shared pairs of electrons are pulled between the nuclei of atoms sharing them. Sometimes electrons are pulled equally and sometimes they are not. This has to do with electronegativity. So recall, electronegativity is the ability to attract electrons. So basically what this is like a little miniature microscopic tug of war. Okay, so if we have two atoms or two elements that have the same electronegativity, they are going to be considered a non-polar bond. Okay, they're going to have, if you want to think of it as tug of war, they're going to be equal in strength. Okay, but if we take a look at a polar bond, we have hydrogen and chlorine. Well, chlorine is more electronegative, so it's going to have a stronger pull. It's going to pull those electrons closer to your chlorine atom. Okay, so okay, all right. So nonpolar covalent bonds, so the electrons are going to be shared equally. Okay, so just like the example we had from earlier, two chlorine atoms, well, they're equal, they are the same. So their little tug of war, well, if they're the same strength, then they can share those electrons equally. Okay, some more examples, or really all diatomic elements are nonpolar because again, they have equal electronegativity. Okay, they're equal in strength. So polar covalent bonds, the electrons are shared unequally due to electronegativity. Okay, so if we are taking a look at, well, let's see what else. Okay, so the more electronegative atom will have a stronger attraction for the bonded electrons and will have a slightly negative charge. And the less electronegative atom will have a slightly positive charge. Okay, so in the case of chlorine and hydrogen again, remember that chlorine is the more electronegative atom and hydrogen is the weaker one. So because chlorine is the stronger one, it's going to pull those electrons closer to it. Okay, it doesn't mean hydrogen loses it, it just means that chlorine is closer to winning that tug of war than hydrogen. Okay, and again, because chlorine is stronger, it's going to have a slightly negative charge. And because hydrogen is the slightly weaker charge, or I'm sorry, the weaker atom, it's going to have a slightly positive charge because it's pulling, its electrons are being pulled closer to chlorine. Okay, so let's go ahead and take a look at the electronegativity values for hydrogen and chlorine. Okay, so we can see that hydrogen is just a 2.1 while chlorine is a 3.0. Okay, so again 2.1 and 3.0. Okay, so which is more electronegative? Well, it's obviously going to be chlorine. Okay, so let's see. So chlorine has a slightly negative charge while hydrogen has a slightly positive charge. And again, it's because those electrons are being pulled closer to chlorine. Okay, and then hydrogen, it's farther away from hydrogen, so hydrogen is going to have that slightly positive charge. Okay, so there are two ways to communicate the polarity of hydrogen chloride. So we can either use these two Greek symbols right here. Okay, so it's going to be the lowercase Greek letter delta. shows that the atoms involved acquire only partial charges. So again, hydrogen is partially or slightly positive. Chlorine is partially negative. Okay, we can also use this arrow right here. The arrow points to the more electronegative atom. Hydrogen, notice how this looks like a positive sign. So hydrogen is slightly positive, and it's moving, the arrow is pointing towards the more electronegative atom. Okay, so again, bonded pairs of electrons. If the ice cream was your bonded pair, well, who's stronger? Who's more electronegative? Chlorine is more electronegative and stronger, so it's going to pull those electrons or that ice cream closer to it. Okay, and on a molecular level, this is what it would look like. Chlorine is bigger and stronger, so it's pulling those electrons closer to it. Okay, some more examples. So water. Okay, I don't think this is in your notes, but let's just go ahead and do it as an example. So is hydrogen or oxygen more electronegative? So again, hydrogen 2.1 and oxygen is 3.5. So oxygen is more electronegative. Okay, so is hydrogen or oxygen more electronegative? Oxygen. So when we label our water molecule, oxygen is going to be the one with a delta negative, and then your two hydrogens are going to be the ones with the partially positive charges. Okay, so let's see. The OH bonds are polar. Okay, so this bond right here, if we're taking a look at this one single bond, okay, this bond right here is polar. Okay, because they are not the same elements. One is more electronegative than the other. Remember, a nonpolar bond is when they are the same electronegativity. So in this case, the OH bond are polar. Okay, so if we take a look at the difference in electronegativities, it indicates the type of bond that the atoms will form. So if they have an electronegative difference of 0.0 and 0.3, then that type of bond is going to be a nonpolar bond. Okay, so again, your example of a nonpolar bond are diatomic elements. Okay, you also have an electronegativity difference of 0.4 to 1. That's a polar bond. So an example of that would be hydrogen and chlorine. The difference between them is a 0.9. So that would be a polar bond. If they have a difference of 1 to 2, then that's going to be considered a very polar bond. So an example of that would be hydrogen and fluorine. They have a difference of 1.9. Okay, and then if they have an electronegativity difference of more than 2, then it's considered an ionic bond. Okay, so example, sodium and chlorine, it would be a 2.1, so it's an ionic bond. And then don't forget, ionic compounds is a metal and a non-metal. Okay, they do not share electrons, so it's an ionic bond. Okay, so let's go ahead and take a look at our last 4 examples. So if we have nitrogen and hydrogen, what type of bond will form? Okay, so I'll give you guys a second to look really quick. Okay, and nitrogen is they have a difference of 0.9. Nitrogen is a 3.0 and hydrogen is a 2.1. So with a difference of a 0.9, then they would have a polar bond. Okay, fluorine and fluorine, you shouldn't even have to do any math, because remember, if you have the same two elements, then they have the same electronegativity. So they don't have an electronegativity difference. So it's going to be a nonpolar bond. Okay, so calcium and oxygen. So calcium has a electronegativity of 1, and oxygen has a electronegativity of 3.5. So 3.5 minus 1 is 2.5. So that means we have an ionic bond. But remember, if you have a metal and a nonmetal, it's given that it's an ionic bond. Okay, and then lastly we have bromine and chlorine. So bromine has a 2.8 charge, and chlorine has a 3.0 charge. So that's a difference of 0.2. Okay, so a difference of 0.2 is going to give us a nonpolar bond. Okay, all right, so summary: a nonpolar covalent bond, remember they have the same electronegativity, so their electrons are going to be shared evenly. Okay, a nonpolar covalent bond, okay, you're going to have one atom that is going to be stronger than the other. You're going to have an atom that's going to be more electronegative than the other. Okay, and then the more electronegative one is going to be stronger, and it's going to pull those electrons closer to it. Okay, and then an ionic bond, they do not share electrons. So one element is going to lose that electron, and the other element is going to gain that electron. Okay, so that's why you end up with a positive charge and one with a negative charge, because it's gained an electron. They do not share. Okay, so your homework for tonight is going to be on page 11. Okay, and if you have any questions, just let me know. Okay, thank you.